The gradient of a distance-time graph. Use the gradient to calculate the speeds for both parts of this journey. You could be shown a distance-time graph and be asked to calculate the speed of different sections. I'm showing you now a distance-time graph that has two parts. We're going to use the gradient to work out the speeds for both parts. The gradient of a graph means the slope of the graph. And to calculate the gradient of a distance-time graph, we need to divide the distance traveled by the time taken. So the gradient for a distance-time graph will give us the value of the speed of any section, and it equals the distance traveled by time taken. So, we need to calculate the gradient or speed for section A of this journey. Let's call this A and this B. We need to know the distance traveled and divided by the time taken. Remember that any journey has a starting point and an ending point. This journey starts at 0 distance, 0 time, and it ends at 120 meters distance, 60 seconds. Each point on the y-axis is called a y point. Each point on the x-axis is called an x point. So the coordinates for this journey are 0, 0 and 60, 120. We can call this x1, x2, y1, and x2, y2. To know the distance traveled, we need to know the distance between 0 distance and 120. So we need to subtract y2 minus y1. And it will give us this distance here, from this point to this point. We can represent this as a line here. And this will show us the distance traveled in this section. It is the difference between y2 and y1. To know the time taken for this journey, we also need to know the distance from this point here to this point here, which is the difference between 60 and 0, so the difference between x2 and x1, and it will show as a line here. So this distance here is the difference between x2, which is 60, minus x1, which is 0. If you look here, you will have a triangle, and this triangle here will help you to calculate the gradient of this section of this journey. So the distance traveled by this journey is y2 minus y1 divided by x2 minus x1. It equals 120 minus 0 divided by 60 minus 0, and the final answer is 2 meters per second. The gradient for section A of this journey. Now we need to calculate the gradient or the speed for section B of this journey. Again, the gradient, which will give us the speed of a section, is the distance traveled divided by time taken. Okay, we need to know the distance traveled in this section, section B. The section starts at 60 seconds and it ends at this point here, in the middle between 180 and 200, so it's 190 seconds. So the time spent for this journey is the time from here to here. Again, we can represent this as a line from this point here to this point here. If we considered 60 as x1 and 190 as x2, this distance, or this time taken here, is the difference between x2 and x1. So this line here is x2 minus x1. The distance traveled in this section is the distance from 120 meters to 160 meters. This is represented as this line here. This distance traveled is the difference between 160 and 120. We consider 160 y2 of this section of this journey, 120 y1 of this journey. So this here is the difference between them, y2 minus y1. So the distance traveled for section B equals y2 minus y1 divided by x2 minus x1, 160 minus 120 divided by 190 minus 60 equals 40 divided by 50, and the answer is 0.8 meters per second. So this is how we calculate speed from distance time graphs. We calculate the gradient of each section to know the speed of each section. The gradient again is the distance traveled divided by the time taken. In order to know the distance for any section, we have to take the difference between the 2 points that this section is coming between and divide it by the difference in the time for this section.